Good morning, students. Once again, I welcome you to my video lecture. Now, to continue with the 2017 EE paper, the next question is on two-port networks. Two, two passive two-port networks, two in number, are connected as shown in figure. A voltage source is connected at port 1. This is port 1. A voltage source V1 is connected. And these two are equations for two-port network number 1. These two are equations for two-port network 2. So we have this connection is what is called as chain connection, also known as cascade connection. Cascade means human chain. Input of one is connected to the output of the other, or output of one system is connected to the input of the other. That is what is known as human chain. So chain connection. So when it is connected in cascade like this, if you find with respect to these two terminals a Thevenin's equivalent, as you know that Thevenin's equivalent will have a voltage source Vt in series with impedance Zt. What is Vt and Zt? Actually, here in the question paper there are 4 options. So rather a lengthy expressions. That is why I have modified the problem, and I am putting this question as to find what is Vt and what is Zt if they are connected in cascade. Now, student must remember one property of cascade connection. When two-port networks are connected like this, what is the resultant two-port network? What is the resultant ABCD parameters? So it is simply the product of the individual two-port networks. If you write in matrix notation, V1 I1, A1 B1, C1 D1, then V2 I2. So this is for two-port network number 1. Next, equations V2 I2 is equal to A2 B2, C2 D2, V3 I3. Now, for the connection, for what is the equivalent matrix equation? Now, matrix multiplication. So, V1 I1 is equal to A1 B1 C1 D1 multiplied by A2 B2 C2 D2 V3 I3. Now I will multiply the matrices. V1 I1 is equal to first row first column multiply A1 A2 plus B1 C2, then A1 B2 plus A first row first column first row first column first row first column first row first column, then first row second column, A1 A2 plus B1 C2, next A1 B2 plus B1 D2, V3 I3, then second row first column C1 D1 plus C1 A2 plus D1 C2, next C1 B2 plus D1 D2. Now I will replace this as A equivalent, B equivalent, C equivalent, D equivalent, V3 I3, V3 I3, V3 I3. Now I will construct the cascade connection. So this is port 1, V1 I1, V1 I1. This is equivalent connection, that is A equivalent, B equivalent, C equivalent, D equivalent. Then I3 V3, I3 V3, I3 V3. Now to find Thevenin equivalent, first with respect to these two terminals, port 3 terminals, first we have to open circuit port 3. When open circuiting the port 3, so I3 becomes 0. I3 becomes 0. Therefore, in this equation, now I will write the equation. First equation, V1 is equal to A equivalent into V3 plus B equivalent into I3. First row, first column. Second row, first column. I am writing only first equation. V1 is equal to A equivalent into V3 plus B equivalent into I3. Now open circuiting the port 3 terminals, that is I3 is equal to 0. Then what is V3? V3, this voltage that appears is what is called as VT. V3 or VT is equal to V1 by A equivalent. V1 by A equivalent. Therefore, VT is equal to V1 by A equivalent. A equivalent is A1, A2 plus B1, C2. B1, C2. This is also one of the answers. Next. Now, to find short circuit current, we have to short the port 3 terminals. So, port 3 terminals are shorted. When port 3 terminals are shorted, this is called as short circuit. V3 becomes equal to 0. V3 becomes 0 and I3 becomes what is called as short circuit current. Now, in this equation, if V3 is made equal to 0, then we are left with V1 is equal to B equivalent I3 or B equivalent into I short circuit. Therefore, I short circuit is equal to V1 by B equivalent. B equivalent is A1 B2 plus B1 D2 Now you recall Thevenin theorem and Norton theorem. What is Z Thevenin? Z Thevenin, ZT is equal to VT divided by I short circuit. That is VT. VT is V1 by A1 A2 plus B1 C2 divided by I short circuit. I short circuit is V1 by A1 B2 plus B1 D2. Therefore, Z Thevenin is equal to V1 get cancelled. Therefore, A1 B2 plus B1 D2 divided by A1 A2 plus B1 C2. This is called as Z Thevenin. Therefore, this is one answer, this is another answer. So, we have found Thevenin equivalent. This is voltage source V Thevenin. This is impedance Z Thevenin, which is V Thevenin divided by I short circuit. So, answers, these two are the answers. So, this is how you have to work out cascading connection of two port networks. Thank you.